So I don't know if you've ever looked at wires. Like, have you ever kind of taken a wire and cut it with scissors and kind of looked inside there? Well, you might have noticed this, that if you have a wire, sometimes it's just like a little tube of metal that sticks out, like I have on the left side there. But other times you have stranding, like a whole bunch of little copper hairs coming out, a whole bunch of little tiny wires that kind of wrap together. And you might be thinking, why are there different kinds of wire? Why are some of them thick like that and some of them stranded? Well, there's actually some important reasons behind this. And when you build your own devices, you're going to have to choose between different kinds of stranding, whether to use stranding or regular cable. And so kind of understanding why we do stranding and when we do it, when we don't do it, is a helpful thing to know. So if you have this situation, where you have these wires, you can kind of have a single piece of metal going through it. That's called a solid cable. Solid cables are tough. It's a single piece of metal going through the cable. It's also inexpensive. You can just fabricate a single, pole of metal. So there's solid conductors. Solid conductors are inexpensive and tough. You get really solid seating into jacks and insulation. Now, on the other hand, you can also have stranded conductors. So these are the ones that look like little hairs, little copper hairs coming out of the wire. Stranded conductors are good at flexing. So you can kind of imagine it. If you have a stranded wire and you're kind of bending it back and forth, the little hairs can kind of slide back and forth against each other in that tube, in that insulation. So they're good at bending. On the other hand, if you have a solid conductor and you bend it back and forth, well, you're bending the metal and the metal's going to wear out. You do that too many times, the metal will break. It'll short out, it'll be a bad connection. Whereas stranded cables don't do that as much. So if you have Ethernet cables, things kind of on your office floor, you kind of moving them around, those you want to be stranded because those are dealing with humans, they're kind of moving around. Whereas solid cables, those are things you put inside walls where you need good connections and they're not going to bend very much. So this is the trade-off. If you want environments where you're kind of moving things a lot, you want to use stranded conductors. Otherwise, you want to use solid ones. So it turns out there's actually different types of stranding as well. And the type of stranding affects the material, its properties, how conductive it is, and all sorts of other things. So there's different types. If you're going to build a cable, then what you could do with a stranding is you could just have a cable, your pipe going along, and a whole bunch of little hairs and just pack them all in there. You could do that. But the problem is it's kind of hard to pack a whole bunch of little of those hairs together. You're going to have kind of a bulky cable. So there's other kinds of stranding which can kind of help you pack things in more. One type is called unilay. So with unilay, what we have is we have a situation where we have the cable and the wires are coming down it and they kind of turn a little bit as they go down. So this is an alternative to bunched cable. Bunched cable is you kind of have all these little copper strands going through and they're just kind of all packed in there randomly. That's bunched. It's inexpensive. You don't need any tricks to kind of twist them together or push them together or anything, so it's inexpensive and simple to build. If you have electrical power cable in your house going to your lamp, it's using bunched cable because that's inexpensive. The downside is it can be bulkier because these little wires are kind of touching each other in weird different ways, and there's a lot of space in between and so on. They're not really packed together intelligently. So there's bunched cable. Then there's different kinds of concentric cables. So concentric unilay is what I'm showing on the right over here. It's something where it's kind of lighter weight and smaller diameter, because what we do is we take the cables and we kind of pack them together and we kind of rotate them as they go through the cable. And the reason we rotate them is this provides good torsional flex. If you have the cable and you have something where it's kind of twisting back and forth like this, unilay is great at that because the wires can kind of just slide against each other as they go through the cable. So it's also got smaller diameter because the cables are packed together more closely. So that's an advantage of using unilay cable. Now there's other kinds of stranding. You can imagine we can pack them together in all sorts of different ways. There's concentric unilay, where we have different layers of unilay on top of each other. There's also contrahelical, where I have a strand of unilay and then a strand outside of that goes in the opposite direction. You kind of have these different layers. And these have trade-offs. If I'm doing concentric unilay, I can have additional strength as compared to regular unilay. Contrahelical provides greater mechanical strength. If I step on the cable a lot, if I squish it a lot, contrahelical is very resistant to that because these different layers kind of push against it in different directions. So contra-helical provides very good mechanical strength and crush resistance and greater continuous flex. If I'm flexing the cable in kind of this direction, that's good. Contra-helical isn't as good for torsional flex because it's not as good at twisting in a single direction. Because you have some cables that are going to kind of bunch outward when it twists and some are going to kind of pull inward when it twists. It's not as good for that. In general, there's also this question of how fast you twist the cable as it goes through the wire. The more twists you have, the improved strength you have, but the more cable it can use. And so there's a trade-off there as well. So if you're dealing with something like Ethernet, Ethernet comes in all forms of these cables. There's solid cable, and that's where you use it when you're running it through walls or in your plenum space above the ceiling. It's used in environments where you're going to deploy it once and kind of keep it there. And you use stranding in environments where things are kind of going to move around if you have a patch panel and so on. And the type of stranding you use depends on the environment. If you're doing something where you're kind of hooking a robot up to Ethernet, it's going to be moving around a lot, you might want to use contra-helical because it'll be good at getting crushed, dealing with industrial applications. You may want to use Unilay, and so on. So when you purchase wire, you can choose whether to use stranding or not, depending on your application. And if you're going to use stranding, you can choose what type of stranding. So it's important to think about when you're building a system, what sort of environments your wiring is going to be exposed to. And then you can make decisions like this when you purchase your wiring.